Hi everyone. So this video is now focused on the H of the vertex form. So we're still graphing quadratics, parabolas. So we're going to go ahead and dive into the H, focus on the H, and it's a horizontal shift. And then the K will be a vertical shift, and that one I will do tomorrow. And then we'll kind of and then we'll do an assignment or a lecture, which will go really quickly, but then we'll do like shortcuts on just visual recognition of what's given to you in the vertex form, and then just go straight into the XY table, graph them, and then I'll give you an assignment with the A, H, and K varying, like positives and negatives. And then we'll play with it for a while, and then we'll start standard form next week, which is the other form. Okay, all right, here we go. I'm glad you're here. Okay, graphing quadratics, vertex form. Y is equal to A, x minus h quantity squared plus k. We are focused on the h this time, okay? And so when I put in the video, I'll say focus h. But anyways, here we go. Oh wait, we're gonna go back to this and I'm gonna refer to this again. Whoops, I just realized I didn't have my left arrow. I know I originally had it right. Right is not left. Okay, your H is your horizontal shift, your X axis. So that means, right, this is your X, Y, right, axis. Okay, so that H is a horizontal shift, meaning it moves left or right along this axis, okay? The zero product property, okay, afterwards, if you were to go back and look at your notes, this will make much more sense when we start, probably in like by next week, when we start having an assignment with everything mixed where the A, the H, and the K are all different values. And then I start going over the XY table based off of this. This will make more sense to you, okay? But for now, look, you just went through zero product property with factoring. Remember, when you have the parenthesis and you set that parenthesis equal to 0, what's going to happen to the H? The H has to inverse operate over the equal sign, so that negative H will become positive H. So X is equal to H value. And so if the H here is negative, it will become positive on the right? Inverse operation. So if this here was X plus H, but really it's X minus a negative H value, you would then take that positive, jump the equal sign because of the inverse operation, and it would be a negative H. So your X value ends up being the opposite of what you actually visually see. And I will go over that, okay? But this is your visual check. Okay, so if the H is positive, we're shifting to the right. If it's X equal negative H, after you perform the zero product property, it will be a left shift. And I just realized I don't have my little arrow. Okay, that's if you solve the ZPP, but if you're just looking by visual recognition, so you're just looking at you're using your eyeballs, you're looking down at the problem, what do you see right off the bat? Is it a right shift or a left shift horizontally, right? If it's X minus H quantity squared, so if this is X minus H, you're going to take the opposite of that value, so you're going to end up shifting to the right. It'll be positive. If you have quantity X plus H quantity squared and you just visually look at it, you should know that you're going to be shifting to the left of the origin, okay? That X axis, okay? So what happens is, just like when you look at A, if this number is positive, you know it's concave up, right? Which means you have a minimum point, you have a minimum value, right? Your vertex. If this A is positive, if your A is negative, you have a negative. It's concave down. It's negative. And so now you have, or your vertex is your maximum point, and then you have a maximum value, correct? Okay, so when we go through the H and when we go through the K, so I'll write this all out for the K as well. And again, if you don't get it right off the bat, no need to worry. When I finally make the assignment where all of these three are varied, I'm gonna go over like these just visual recognition, first check. You should know from just looking at it what you have an idea, so that once you graph it, you should be able to double check to see if you confirm it. You want to be in the video. Okay, so here we go. This is what we're going to graph. Y is equal to 2, x minus quantity x minus 3 squared. Pick it up. Plus 0, or y equal to quantity x minus 3 squared. Okay. Remember, the k value is 0, but we just assume it to be 0. So if it's not written, it's really this. Okay. Okay, here we go. So as you notice, I'm definitely just, okay, you're back. Right, I'm just writing them shorter. Okay, what is the A value? Your A value, right, is here. So this is AHK, right? Oh, I forgot to put what the H value is. Oh, I'll put it off to the side. Huh, that's what I'm focused on, right? This is what I'm focused on, and I don't have it here. Go figure. Okay, so what's my A value? It is positive 2. So if you want to write a positive 2, that's fine. Or you could just write 2. It's up to you. Okay, is the A value positive or negative? It is positive, right? And if you wrote POS for abbreviation, it's fine. We got that on the test a lot of times, so it's good. Okay, is a parabola concave up or concave down? If it's a positive A value, that means it is concave, right? The concavity is up, so it looks like this, right? Okay, so with that, does a parabola have, oh, I forgot to take my markers out. Oh no, I do. I don't even know what I'm doing. Okay, does the parabola have a maximum or minimum point? I have so many papers. I have all the papers on top of the markers. That's why I didn't know. Okay, so does a parabola have a maximum or a minimum point, right? So you should know that. The vertex would be here, right? The vertex is at turning point. So if it's going to be at the bottom because it's concave up, the vertex point is actually the minimum point, which means it's going to be the minimum value. Okay, now, does the parabola have a maximum point? Remember, it is the point of your vertex. So whatever your vertex is, that's the same answer. Okay, your minimum value is your y value of the vertex. So when you find this vertex, which is a point, right? This is a point. That's a point. Okay. We'll come back. So once we fill out the XY table, we'll come back to it. Okay, your Y value of the vertex is this answer. Okay, what is the axis of symmetry? It is the X value of the vertex. So it's going to be, now remember, this is a dashed vertical line. So this is going to be X equal, and then whatever that H value is. So it's also the H value, X equal H, right? Right, because remember that number is what fills in for our XY table. Okay, so we're going to come back to it. So we're going to come back to the orange marker because I'm going to use it on the XY table, okay? Okay, so here we go. I have two tables. This is the one we're actually going to solve. This is the one we're going to kind of just focus on as far as the vertex. Okay, so your vertex is your HK value always. That's why this is called the vertex form, because what is given to you, the vertex, what is visually recognizable, the vertex. Your vertex is HK, okay? So the reason why is your vertex is the point HK. Okay, now what happens is now in, not in marker, in pen, we'll get to the K part because right now we're just 0, but I'm going to tell you what to do. So you just hear it a day earlier, not a big deal. But what happens is yes, because of the zero product property, you set this quantity x minus h equal to 0. You solve it. So if it's x minus h, you take it over, right? You're going to see me do that. But shortcut, what are we talking here? Okay, what you see, because of the zero product property, the vertex H is going to end up being the opposite of what you see. And you'll see in a second. And I'm going to keep referring back to this, okay? The K value, it's going to be, I need to keep my hand there. Okay, it's going to be the same or if you follow it. So you're like, what are you talking about? We'll get there, okay? Okay, so if now we come down, because remember, these three, I like filling them out after we do the table or even after we plot it, then I come back. But if you are getting it, go ahead and write them out. Okay, we want to focus on the table. your vertex is the HK value. Now, when you look at your vertex form, this is my A, right? A. My K is at the end, so that's O. And my H here is -3. Or at least that's what it appears. Okay, but let's get a little sheet of paper. Okay, what you have, or what you see, is y equal to x minus 3 quantity squared plus 0. And you would say, oh, A, H, K. Okay, A is 2, K is 0. So far, your eyes are not deceiving you. Beautiful. However, H is not -3. Remember, it is x minus the value of H. So this -3, you're thinking that this negative is attached to the 3, but it is actually not. If we were going to be super, super technical, it is x minus, right? Because remember, that's the vertex form. And I substituted the value of 3 inside. So this is in fact K. This is in fact A. This is H. H is actually equal to +3, and that's why in the vertex, and I'll refer back to it in a second, that's why when I wrote vertex up here, I told you to go opposite H, follow K. The reason why is Y is equal K. Okay, so you have Y on the left, equal sign separates them, 0 over here. So you're going to go ahead and follow that. H, on the other hand, H, right, and X are on the same side of the equal sign, which is why, shift over please, which is why we have to perform the zero product property. And so it's not just x minus h, so what I see is what I follow. No, you have to set that quantity equal to 0. So when you see here x minus 3, you're seeing x minus 3. But what happens, you have to inverse operate to isolate the x, so that -3 jumps over the equal sign, and that's inverse operating or adding. And so that would be x is equal to +3. And so if x is equal to a positive number, and in this case, x is equal to +3, we are going to have a right shift. So when you see x minus 3, you're looking here, x minus 3, where you're looking at something that's negative, but is in fact a right shift, because of the zero product property. And so when you look at the vertex form, you opposite H, follow K. So I would actually have a vertex that is +3, 0. And that is what that is how I'm gonna fill out my XY table and find my other two equidistant points. Okay, so zero product property, it's then x minus, and then the substitution of h is +3. So if you would have performed the zero product property, x, this paper is so small, I'm trying to keep it steady with my wrist and hand. Perform the zero product property, +3, x is isolated, and +3 is on the other end. And so that is the value of h. And so that's why we say opposite h, follow k. Okay, so move that over. Okay, so my vertex, you guys have been wonderful. You know, you put it in that third slot just to help me out with equidistance, always. So then my vertex here is +3, 0, right? Because here, and I just realized, like, nowhere here did I ask you for the HK. So we'll just write it here. Okay, so my H value is +3 and my K value is equal to 0, because I'm going to follow what I see in the given vertex form equation, but I'm going to go opposite what I see in the vertex form quadratic, right? So I see, well, here, -3, +3, 0, 0. So Opposite this, follow that. Opposite, positive 3, follow 0, 0. By the way, 0 is an only positive number. It's the only number that can only be positive, so that was an easy one. Okay, so here's my vertex, 3, 0. Keep going. Okay, so now comes your equal distance symmetry points. You can go down 1, down 2, up 1, up 2, or however, some of you have switched them, but yet you're all understanding the fact that you're going to go 1 away, 2 away. So what I mean by that, just because they're a little different, because now we're starting at 3. Okay, here's the number line. Here's 3, right? If you're looking at the number line. 1 unit is 4, so 1 unit is 2. So I'm going to go 2, 4, and these two are equal distant from my 3, right? From my H value, my vertex. And so they should have the same equal Y value output, right? Okay, so then I'm going to go 2 units to the right, that's 5, and then 2 units to the left is 1. So 1 and 5 are equal distant, and so those two Y values or those two input values should be equal, right? So it's not that much work. You have to realize I am talking so much through this because this is introduction. Once you start solving them and once we get faster at it, it's really a fast problem, okay? Okay, so let's solve. Okay, so here we go. Let's input. Okay, so let us put x is equal to 1. And remember, the original equation is y equal to x minus 3 squared. There is a 0 here, but I just kind of copied it. Okay, so I just have it written once so I don't accidentally screw it up, okay? All right, so we're going to let x equal 1. So y is equal to 2. 1 minus 3 squared. And if you want to write the plus 0 or you don't, it's fine. It's up to you. Okay. All right. Order of operations. We could just leave this out. Fair enough. Right? It says plus 0. What's the point? Okay. Order of operations. You gotta do this first. Okay. So I get y is equal to 2. 1 minus 3 is negative 2 squared. Right? That's parentheses, right? Remember parentheses. Now we're going to take care of exponents. Exponents. Oh, whoops, sorry. That's, oh, but I should do it on another line so that I can mark it. 2, that is 4. And now you're going to take multiplication. And so I get 8, right? And so I substituted 1. Okay, so 1, 8, 5, 8, right? Okay, so now let us take x equal 2. So y is equal to 2. 2 minus 3 squared equals, I'm putting equals 0. It's because I was going to solve it. Okay, so here we go. Parentheses first. This guy right here, right? So y is equal to 2. What's 2 minus 3? Negative 1 squared. Right? Next, we're going to take exponents. And so we're now going to take this negative 1 squared. It's because I haven't moved my elbow. It's still far away. So, and now we're going to multiply. And we're going to take care of that. And we get 2. Easy, right? Order of operations. Know how to perform your arithmetic. So important. Like so important. And so you get 2, 2. Okay, so that's our XY table. So the XY table actually is not a lot of work. Like here, it's my HK value, right? So I go opposite H, follow K. So if I come here, opposite H or opposite what you're seeing, H is actually 3, but what you see is X minus 3. So you're looking at a negative 3, but it's actually a positive 3. That's why you go opposite what you see. So what's my vertex? 3, 0. Boom. Here's my 3, 0. Go 1 distance away, 2, 4. Go 2 distances away, 1, 5. Plug it in. There's your XY table. Beautiful. Just so pretty, so predictable. Consistent, gotta love it, right? Unless you make a mistake, then it's like super frustrating. And you'll know when you plot the points and it goes off a little bit of a bump and you're like, what the heck? Don't feel bad. It happens to me. Okay, so now we're gonna plot those points. Okay, and then I'll come back and answer those questions. Okay, 3, where am I going? 3, 0. Oh yeah, so here are my points. But I didn't, okay, I'll write them right here because I kind of squished. 1, 8, 2, 2, 3, 0, 4, 2, 5, 8. I would have normally written them here, but I forgot I should have shifted my work over, so I apologize. That's why I always try and rewrite everything ahead of time so that everything has its proper place, but I messed it up. Okay, 3, 0. Remember, you're going to take the number first. So if you want to go 1, 8 first, that's fine. Okay, 1, and then I'm going to go up 8. So 1, 2, 3, 4, 5, 6, 7, 8. Let me just double count that. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 1, 8 is here. 2, 2, 2, 2 is here. 3, 0, here's 3, here's 0. 4, 2, and 5, 8. Okay, and then as best you can, I'm gonna try and round it out. Make it pretty. I know I do mine in pieces. If I had both hands, I would do a little bit better, but I'm trying. Okay, and so there's my parabola. Okay, really quick, our axes of symmetry. So I'm going to take it in pink because now your axes of symmetry will now be really visible. So that's what's nice about this. Okay, remember your axis of symmetry is a dashed vertical line that intersects or runs straight through your vertex. So this is my axis of symmetry. It is always a vertical line, always, always, always. So it is not just 3, it is x equal 3. It is always x equal that h value of the vertex. I'll come back to it. Just let me remember, you guys can pause whenever you need. Okay, so what is the axis of symmetry? X is equal to that h value. So I'm going to do it in pink just because that's what it is on, I'm going to write it in pink. I know I say do a lot, sorry. So x is equal to positive 3 because that number is the same number here, h. Okay, and remember that hk comes from here, right? Okay, so here's my graph, x equal 3, right? Oops, there we go. Okay, let's talk about your maximum point, minimum point, and of course, oh, I guess right in green. Okay, this is my vertex, right? Here, right? That is my vertex. My vertex is 3, 0, correct? Remember, this is my h value, this is my k value. Okay, or your x and your y, right? Because every point is x, y. I know we're giving everything different variables, but you need to understand the synonyms of life, which you do. Even your speech, you understand there are synonyms, right? Okay, so here we go. So in mathematics, same thing. Okay, so does your parabola have a maximum or minimum point? Okay, if you have a positive or concave parabola, your vertex is at lowest point. Your maximum or minimum point is always your vertex. So remember, our vertex is 3, 0. And that is our minimum point because it is the lowest point in our parabola, right? It shoots off to infinity. Infinity, it goes on forever. There's our lowest point. Okay, so now what is the max or min value? If it's a minimum point, it's a minimum value. And that is always your y value, which is the same as your k value. So here my k value is 0, or you don't see it. It's also here on the table. So it's just 3, okay? Don't put y equal 3. I know I have x equal h there, but I just meant that they were the same number. So put or. This is a vertical line. Minimum value, it's just a point. It's just the y value, okay? So it's just 3. Okay, so that is, no, it's not it. I was going to say. Okay, so now just to summarize really quick, remember the whole point was we're focusing on h. I'm so sorry. We're almost about to hit 25 minutes. So thank you for listening. Thank you for watching. Okay, afterthoughts. This was our quadratic, y equal to quantity x minus 3 squared plus 0. If you see a negative, remember, you go opposite h. So it's not negative 3, it is positive 3. So I'm going to make a right horizontal shift. So describe your horizontal shift. Right 3 units. And remember, right is your x, right? It's on the x-axis, not the y-axis, right? The k will be the y, and it follows the same rules here, except you don't go opposite. Okay, thank you so much. I will put up an assignment. I think I covered everything. Okay, goodbye.